Okay, so hopefully you feel quite confident about atomic structure itself. Now, I'd like to now focus on what you learned from the exercise just then. What do numbers you see on the periodic table tell you? Okay. Firstly, atomic number. What does it tell you?
How many protons and therefore electrons?
Oh, good. Both are correct. Atomic number tells you, come on, respond. Number of protons in the nucleus, hence the number of electrons. Good. So, hang on. Periodic tables. I forgot to switch camera. So atomic number to start with, number of proton.
So do we write what's on the calculator?
What I'm writing.
Numbers at the periodic.
Atomic number. Yeah.
Who did that horrible Your American accent is I really don't.
I'm using different colors here, not according to the importance of them. I just usually associate, positive particles with red, negative with blue, and neutral with green as well. That's atomic number. What about mass number? What does it tell you again? What did you say? What did you learn? I want some other people as well. Yeah, Josh?
Mass number equals neutrons and protons. Right?
Neutrons and protons?
Yes.
That is correct, yeah. So, it's the how many particles are in the nucleus, yeah? Oops. Different color.
Means number.
Number of protons plus number of neutrons. So how would you find number of neutrons from what you know? Well done. That's really what you should do mathematically.
Wait, you do that for what?
I'll write it here.
Thanks.
So to find neutron. You do. So write what you're seeing on the board instead of copying down everything. For example, well, let's do chlorine. in chlorine, how many neutrons are there?
17. Wait, you said neutral?
Yeah.
17, don't worry.
What did you do as a calculation? So that's something you have to refer to the periodic table. So number of neutrons can be found if you take proton number from mass number. Mass number is 35.45, 36 maybe. So let's use whole number here. I think you can. Yeah, it would be. Yeah, 35.4. So yeah, let's put it as 35. Take number of protons, 17. What would that equal to? Thank you. Yeah, that's done. Yep. That's really how you do. When you're given mass numbers in your whole number or number of neutrons, if you're counting number of protons and stuff, yeah, just use whole number for most of the time. Now, what you might then ask is, why aren't all the numbers that you see, the mass numbers especially, they aren't the whole number? Why do you think that they are all in decimals? Yeah?
That's the actual correct amount of neutrons and protons. Yeah, because you can't actually measure the numbers probably.
Ooh, okay. Good interpretation, but it's not quite right. Not quite right. It is okay. It's okay to make mistakes, and that's good. Yeah.
Rarely mass is rounded to a specific number. Like you rarely ever get a mass of something being one whole thing. So it's just realistically, there's going to be a couple of decimal places.
Maybe, yes. Well, if you're using the unit that you saw before, AMUs, but you're only counting number of protons and number of protons. Oh, that's a good point too. But that's something that we are ignoring at this moment. Good guess though. All right, here's the answer. Now, I was using this example with Joel and Damon, thank you. I was talking to those boys saying that they're both, okay, Caucasian boys. Yeah, same species. You don't look Asian enough to be, different species, so. Two Caucasians. Alright, now, so two boys, same age, you can consider them as same species, right? But they would ought to have different mass. Maybe they ate different things. Maybe one of them had too much pizza last night. It depends, right? Well, what I'm trying to get is, even though they're same species, some of them, in fact, if I consider all of you, year 10 chemistry class as a whole, and if I consider all of you as just human, yeah, we all have different mass, don't we? Yes? What would cause that in atomic level, in each atom is that some, say, if you consider all of us to be a carbon atom, some of you would have lighter weight than others, or even heavier weight than others. Why? We are still talking about carbon, so you all have 12 protons in it. What makes the difference then?
Because they're in different forms.
Different
Forms, like the carbon is in different forms.
You are still talking about the same element. So you're still carbon. And we are looking at comparing atom by atom. So let's ignore the form of it. What would affect the mass then? You can't change the number of protons, therefore, what can you change? Thank you. Electrons will be the same as proton, remember that? Neutron. Okay? Now, imagine that, say, 90% of you have 6 protons and 6 neutrons, yeah? But, say, I happen to have one less proton. So I would have 6 protons, meaning I'm still carbon, yeah? But I'm 1 AMU lighter. So I might be 11. That's not realistic. But most of you would have 12 as its mass, but maybe some of you might have 13. Some of you might be 14. Okay? But the ratio will be really, really low compared to 90% of you being 12 as mass. Okay? If you take the average, what's going to happen to the mass number? Would it be 12? No.
No, because there's other numbers.
Yeah, because of other numbers. There are some 13s and 14s. So you would have 12.01.
Oh, that makes sense.
Okay? Does that make sense to everyone else too?
No, that makes sense.
Okay? Next slide might makes more sense. Alright. They are called isotopes. Here we go. Definition of isotopes. What are they? Alright. Atoms which are the same elements but different mass. That have the same number of protons. Different mass, let's also say due to different number of neutrons. Upside down 3 dots is not therefore, it's because. If you haven't used that, use it in math. I'm pretty sure Mr. Archer will be happy. Because.
Positive charge and negative charge.
No, upside down, 3 dots. 3 dots is usually therefore, right? You can do because if you make it upside down. Have different mass because of different number of
Mr. Kikuchi, in chemistry, doesn't matter where you place the electrons, or does it just have to be 2 in the shells and then outside 8?
I will talk about the rules probably. Well, next week we will do that.
Is it always like same? Like I'm saying, like
There has to be 2 on the inner shell,
first shell.
and then I don't know the outer shell.
Eight on the outer
There's
shell.
8 options, or all you have to use all 8.
2, 8, 8, 18.
It doesn't matter where you place it.
Well, within the shell it doesn't matter.
Yeah,
But
that's what I
for say us markers, it's easier to see if you split them into one at the top, one at the bottom.
Yeah.
On the next shell, if you equally separate, spread them out, it's easier for me to mark.
Yeah.
Meaning you don't get the wrong answer. Okay. Now, common ones.
Wait, so they're all like still called carbon, but
So the example I was using, I was referring to this. Most of the carbon atoms have got 6 protons and 6 neutrons. If you add them up, you get 12. That's most of them, alright? But there are certain percentage of them which has got 13 as its mass number. Why? It's still 6 protons but 7 neutrons. Some of them even have 14, 6 protons and 8 neutrons. Okay? Now, have you heard of carbon dating theory? It's not about carbon atoms dating. It's about you using carbon 14 or 13 decaying to find how old things are. Where would you use that for? Anyone? Fossils, trees which have been buried for a long time or have died. Anything else? Basically archaeology type of thing. Yeah, you can use carbon dating technology to find out.
On dead bodies.
Yes, because carbon 14 gets carbon-14 do not get created in the dead body. So if you find a dead body which was mummified and from a long time ago, few thousand BC, you can check the age. Yeah, from the time that thing died, the person died.
I was going to say, I don't think it's still a person.
Sorry, mummified body.
Question. With carbon and carbon monoxide and carbon dioxide, is that what you were talking about with different forms? Or is that a whole different
Whole different
together?
compound.
Yeah. Okay.
That'll be CO2. It's combined with oxygen, so different thing.
Carbon monoxide,
Monoxide.
is carbon.
Yep. Sorry. Another thing is what Homer Simpson does. Now, uranium is something that's mined a lot in Australia, and that's quite controversial, wasn't it? I hope you remember, or you have learned something about uranium mining in Australia.
No.
No? There was even voting for it. Why were you voting? Why were we voting for it? I'm not Australian citizen. I didn't vote.
Because it's
But
dangerous.
uranium comes from, that's the heaviest naturally occurring element. Okay? That's why it's in, so 92, you see that in a bold black color. If it's not filled in black color, that means they're all man-made, artificial. Okay? So heaviest element that appears naturally, that you can dig up, right? What do we use them for? You can use them for nuclear energy.
Like that.
Australia can sell them. Yeah? Australia can sell them, but what happens to the waste that comes out? They're all radioactive and it's going to be very dangerous. What do they want to do? Countries like India. I don't want any more Godzilla incident. So you don't want to dump in the ocean. Okay? Now, only thing that we can do with the nuclear waste is to securely store it somewhere for 1,000 years. Then they will become not really radioactive anymore. Okay?
Yeah, but that's what they tried to do elsewhere, and people were like dying.
Yeah. The thing that we have voted was, it's highly social, so I would like you to know, because it's to do with the future. Well, that's where you're going to be living in. Okay. So the voting that happened was to see the interest for us to get money to let people use the land to store the nuclear waste. Okay? Because Australia has got outback that's large enough for another country to ship their uranium waste back to Australia and store. Now Australia can get a lot more money, yeah. So economically that may be good. But where does that land belong to? Well, that would be Aboriginal people, those people who belong to the land. Yeah? So that's a controversial stuff that you have to think about, isn't it? Okay? Only some portion of the uranium has got the right amount of neutrons that can be useful for nuclear energy. So not all uranium mining will create money. Okay? Only certain portion of uranium can be used for that. So is it worth still digging them up, selling to other countries? That's something we need to think about, right? So uranium also has got a lot of, at least 4 or 5 types of, what do you call that? Isotopes, okay? Right, I talked a lot. I would like you to do an activity. And this time I would like you to focus on learning first 20 elements. And my expectations are you will learn name, symbol, atomic number of first 20 elements. Now,
Remember the name?
you will have the periodic table in the test. So you can still refer to them. Yeah? But it will save a lot of time if you knew the name, symbol, and in what order they appear. And maybe use this time to start doing that. Now, you can do that by using the flashcard Quizlet. There's a link here.
Is there a game version?
Yeah, let's do a game actually. Alright, if you can go to Have you done a Quizlet live before?
No.